Prop 28 says, if a straight line falling on two straight lines make the exterior angle equal to the interior and opposite angle on the same side, or the interior angles on the same side equal to two right angles, the straight lines will be parallel to one another. So this is kind of an interesting one. It's really similar to Prop 27 in terms of, just some of the conditions that prove that two lines are parallel. And this one is naming out what appears to be two separate conditions. So if the exterior angle is equal to the interior and opposite angle, meaning if EGB is equal to GHD, right? So yeah, if EGB is equal to GHD, that's the first condition that says, well, if that condition is met, then AB and CD are parallel. The second condition that is stated is if, let's see, what does it say? The interior angles on the same side are equal to two right angles. So if BGH plus GHD, if these two angles taken together are equal to two right angles, then again, AB will be equal to CD, and that seems like two different conditions, and in Euclid's proof, he treats them as two different conditions, but those are actually equivalent. If the interior and opposite angle, if the exterior angle is equal to the interior and opposite angle, that is true if and only if the interior angles on the same side are equal to two right angles. And you can prove that pretty easily using Prop 15 and some of the common notions. And it seems to me, though, that I'm sure that Euclid recognized that those are equivalent. My speculation for why he treats them as being different and just does it all in one, proves it to be true for both cases, is just because to first prove these to be equivalent statements, that's kind of that's something that needs to be proved itself. So that would kind of operate like a lemma to this proposition. So for him to do that, he would probably, the way he was viewing it, and this is just speculation on my part, probably the way he was viewing it is he didn't want to create just another separate proposition just to prove this one, even though today we might consider that to be a cleaner way of doing this. He instead just felt like, I'll just make one proposition because it can kind of all be done in, proven in one proposition. So anyway, we do have to treat this because we haven't proven that these are equivalent statements, which again, you could go through. It's a great practice. It shouldn't be too hard to prove that those are equivalent statements. It's an if and only if statement, so you have to prove it two different ways. But rather than doing that, since we haven't proved that to be true, we do have to treat them as completely separate, independent situations, and we prove the result for both of the situations. So proof. All right, so we'll start off by assume angle. So this is the one where we're assuming that the exterior angle is equal to the interior and opposite angle. So we're going to assume that angle EGB is equal to GHD. And then the conclusion should be then that AB is parallel to CD. So that's what we are aiming for. All right, well, if EGB is equal to GHD, we also know that EGB is equal to AGH. And that's by Prop 15. The one that I was just saying you could use that to prove these to be equivalent in any case. So by Prop 15, it must not be Prop 15, because I think Prop 15 is the alternate angles. Which one am I thinking of? Let's see here. I must have gotten them wrong. Prop 13, sorry, not Prop 15 that proves those equivalent. Prop 13. Prop 15 is the one that says alternate angles are equal. So Prop 15 says that AGH is equal to EGB. Yep. So EGB equals angle AGH. because they're opposite alternate angles. So, yep, Prop 15, which means then that AGH is equal to GHD. By the common notions. But then notice, what are we looking at? We're looking at AGH and GHD, which are alternate angles. Alternate by the definition that was set out in Proposition 27, or maybe not definition, but the way that it was used in Prop 27. So, since angle AGH and angle GHD are alternate, it follows that AB is parallel to CD, and that comes from Prop 27. So that's the first part that we wanted to prove. And again, because these are actually equivalent, we've just proved the whole thing, but we didn't prove that these two conditions are actually equivalent, so we have to prove it for the second scenario as well. So that's what we wanted to prove. Now we're moving on to the second situation. And in this case, we are assuming that angle BGH plus angle, I just want to make sure that I'm setting this up right, that he's not just jumping straight into things, because sometimes he leaves a little bit out. So yeah, we're assuming that BGH and GHD is two right angles. I'll just say two rights. Alright, so this is just something that we're assuming. This doesn't come from a proposition we're saying, hey, assume that this is how the setup is. Alright, well, what else do we know? We know that AGH and BGH, those form, yeah, here comes proposition 13. Those form two right triangles. So by Prop 13, we know that angle AGH plus angle BGH, yep, equals two rights. So yeah, that was Prop 13 that says that. Well, then we have this sort of transitivity of equality, because BGH plus GHD is equal to two rights, which is also equal to AGH plus BGH, so these are equal to each other. BGH plus GHD equals AGH plus BGH, and they have this common piece, BGH. So we can conclude then that angle AGH equals angle GHD. So AGH equals GHD. And again, these are alternate. So since angle AGH and angle GHD are alternate, the conclusion follows. AB is parallel to CD. And again, that's the same reason as earlier. Prop 27. So again, those are really the exact same conditions, and I think that's a really smart little proof to do. Can you prove that these conditions are actually the exact same, that angle EGB equals GHD if and only if BGH plus GHD equals two right angles? Shouldn't be too tough for you, it's just a couple of lines. So in any case, that's the end of our proposition. QED, therefore, etc.